Welcome to qnawire.
Hello, today I'm going to be walking through the problem where we figure out the time that it takes for an electric wheel to grind to a stop, and then also what angle it will travel through as it comes to a stop. In this problem, we can think in the start about some wheel just turning with some initial angular speed, omega I, and then at the end it's stopped, it's no longer spinning, and we have some final omega or uh, final angular speed of 0 radians per second. So let's start with what we know from this problem. In the problem, it gives us the speed that the wheel starts at, which is omega I, and it tells us it's 1 times 10 to the 2 revolutions per minute. It's important that right now we think about the units that we need to use in the formulas we're given. In the formulas you're given, you always need to use radians per second, radians and seconds. So revolutions per minute doesn't really help us very much. So we need to convert that answer into radians per second. The way we do this is that I know that there are 2 pi radians in a revolution because it's gone around in a circle. And then also I know that 1 minute is 60 seconds. So if I multiply these together and then divide by 60, I get 10.5 radians per second as my initial angular speed. As stated before, it comes to a stop, so my final angular speed is 0 radians per second. And then I am also given an angular acceleration of negative 2 radians per second squared. So the first part, we need to use the formula change in omega, or change in angular speed, equals angular acceleration, or alpha, times t. And we are looking for t. So when we talk about this problem, when we solve it, we're going to start with the equation I have laid out here. Change in omega equals alpha times t. And then we need to solve for t. So the way we're going to do that is we're going to divide each side by alpha. And then we get time equals change in omega over alpha. And then change in omega equals the final minus the initial angular speed. And we divide that all by alpha again. So now that we have the formula, we can plug in our numbers. We get t equals 10.5 radians per second minus 0 radians per second. And then we divide this whole value by negative 2.00 seconds. Oh, and actually, there's something that I've done here where I have switched these two around. So you actually would want to switch these because your final is 0 and your initial is some number. And that'll make a difference when we get our answer for the time. So make sure that you have these switched around. The reason I did this is because I'm usually used to having, the bigger number first. So that is what happened there. But what you'll end up with is negative 10.5 radians per second. And then you'll divide that all by 2 radian, or negative 2 radians per second squared. So now I'm going to get a negative and a negative divided, and that's going to give me a positive, which makes sense for time. So that's one way you can check yourself to make sure these are in the right position, is if you get a negative answer and you have a negative on the bottom and you need time, that should work out. So when you divide these, you get a final time of 5.24 seconds. And that's how long it takes the grinder to come to a stop. Next, we're going to move on to question B. In this case, we are figuring out what angle you're going to go through this entire time. So we're going to start with this equation where we know the angle that you travel through is equal to the initial angular speed times time plus 1/2 angular acceleration times time squared. So we just figured out time, so we can plug that in, and we know the initial angular speed as well as the acceleration. So we'll find change in theta equals, let's plug in for omega initial, that is 10.5 radians per second. Multiply that by 5.24 seconds, and then we add 1/2 times negative, remember that negative is important, -2 radians per second squared times 5.24 seconds, and then we're going to square that number. So what you end up getting when you multiply and add everything together, your final answer is 27.4 radians equals my change in theta. So if you're not getting this final answer, I would make sure that you are paying attention to this negative sign there, and this squared. Those are probably the two things that people do that most commonly will change this answer. And I hope you like this explanation.